We're live. Hello, world. Random LeetCode. Today we'll do a medium level problem, randomly chosen, and hope it's being shared. So let's restart the clock. Problem 429. N-ary tree level order traversal. Given an n-ary tree, return the level order traversal of its nodes values. N-ary tree input serialization is represented in their level order traversal. Each group of children is separated by the null value. See example. Serialization is represented, but I mean, the input is the root of a binary tree, given an n-ary tree. Okay, this is the serialization. Okay, so we have this tree that has not two children, which is not necessarily two children, which is what the maximum that a binary tree can have. But n-ary can have many children. Any node can have many children. Do we have any limitations? We have, so the height is less than or equal to 1,000. The total number of nodes is between 0 and 10 to the power of 4. But there is no limitation of how many nodes any node can have. I mean, the total number of nodes is that. So we could have the root and 10,000 minus 1 children. Okay, so that's kind of the definitions as I understand them. So in 1, 3, 2, 4, so that should return. We should return a slice, an array of arrays. In this case, slice of slices in Go case. So the first level will be 1, then 3, 2, 4, and then 5, 6. Okay, in this case, it will be 1, then 2, 3, 4, 5. So level by level. So this sounds like a breadth first search could be a good solution. Using a queue, so we'll need a queue, which will be a slice of nodes. Initially, the queue will have the root. And we also need to return our result answer, the slice of slices of integers, right? Initially empty. Do we need to put the roots value here? I don't think so. So we're gonna do breadth first search using a queue data structure and two nested loops. One loop will be for length then of queue is more than 0. So as long while will be a while loop that keeps running as long as we have something in the queue. Okay, then and the other loop will be going through the current level size, which will be the current length of queue. And what else do we need to do? I mean, so we get this initial batch, this queue, which has some number of nodes in this current level. All right. We need to do anything else here. So, and then we'll start. We'll be collecting. So we'll be doing two things. Collecting the values of the nodes, starting with the first one in the queue. So we have this now is queue, and queue is queue. So we get the first value, we put it in the answer, and now val. And that's one thing we need to do. But we also want to get all the children of that node, and that will be another loop. Yeah, because when we deal with a binary tree, we have a maximum of 2 children. Now we want to use a loop over the children for so child range I'm going to be ranging over now children. And for each child, we will add this child to the queue. So we'll say that queue is append queue child, basically like that. So we'll go through the children. And by the way, do we need to, because I mean, if we don't have to do anything else, if there is no children, yeah, so with this kind of approach, if there is no children, then this loop will do nothing. Yeah. So we'll check no. Yeah, but I mean the other approach would be to say that Q is append Q now children, but if that value is nil, then and that's a slice, so we need to put it one by one. So that's another way, but if it's nil, it will append something. So that approach will not append anything. But if in this case, if it's, we need to check if now children is not nil, then do that. Yeah. So it's, I don't know, whatever you like. But if we just do the line without checking, that will create in the queue values and empty values, which we will process so for nodes that has nothing, no children, we'll still add just an empty, will we? So now children will be a nil slice. I wonder how it would work, but let's, because I mean, we're pretty much done, I think. Answer. Yeah, so now when we will try to work or go over this nil slice, decompose it. Yeah, when we try to do that, we will try to do that. It's I think, well, intuitively I thought it would append a nil or actually it could return an error saying you're trying to there's three dots. You're trying to three dots meaning ellipsis. Yeah, so three dots can mean different things. Unpack it. You can unpack. Well, yeah, that's kind of, if you try to unpack an empty slice, I'm afraid you're going to get a, so to be safe, I mean, we can try that, but to be safe, let's try the more, okay, cannot use now val type as slice of integers. Now val, we're going to append. Oh. Yeah, so yeah, I thought it would be too simple. So for each level, we need to create a slice. We need to append. Yeah, we need to create a slice. Level is an empty slice of integers. And we will be appending to level. And at the end of our work with level, we'll append level to, yeah. So we'll append, not, in this case, it will be answer and it will be level. But in this case, it will be level, append level, now val. Yeah, so I think like that. Yeah. And let's run it. Runtime error. What? Invalid memory address. Runtime root. Oh, so if the root is empty, because based on there could be a number of 0 nodes. Yeah. So if root is empty, then what could happen is so we'll get that root will be put in the queue. That nil and what level size, length of queue, level, we'll create level and we try to range level size, and we get the queue 0 and queue it, and then we try to access the value of that nil. Yeah, so, well, the basic approach is, yeah, if there is nothing, yeah, if root is nil, return nil. I guess it's that way. Yeah, we need to use that test case. Oops. And it should work. Yeah. Let's see. Yeah, so it works. Yeah, and I want to try and see if it's going to work with, I mean, it should work like that. Error unexpected name string. Oh, wait a second. Uh-oh, typo. Yeah, so it works. But what if we just do that append? And that also works. I'm not sure. I mean, we will create a lot of, I think that should be creating empty, but but it works, yeah. So anyways, 18 minutes. In 18 minutes, we solved a medium level problem. And this is a problem within the first 1,000 problems on LeetCode. So it's typically one of the classics. Not too long, good interview size, byte of code. And yep, looks good. Using breadth first search to go level by level. 20 minutes. Thank you for watching, and we'll see you in the next video.